Okay, today let's investigate the diffraction phenomenon a little bit. Especially, I wish that we can get why we got this equation n times lambda equals to d times psi theta at the end of this series of video. Okay, so first, what is diffraction? Diffraction basically is the spreading out of light or of wave. Whenever any kind of wave, right, even a water wave or electromagnetic wave, whenever it travels through a very narrow slit like this, so then the slit will have a width like from here to be as d. Okay, so what does it mean by spreading out? It means that at first the wave is kind of travel in this direction. This is like the v initial, okay, and we kind of familiar with these planar wave front, right? If you want, just have a look back at the Huygens principle and also the model of it. Okay, we can talk more about this in another video. But basically, I will assume that you know what is the Huygens principle already and what is the model of the wavefront, and also like for the propagation of wave. Basically, like the way the wave travel in space, it can be represented by a v vector, that the wave speed, the wave velocity, and it's always like perpendicular to the wavefront. So if we got the wavefront like this, then this will be the propagation v vector, okay? If the wavefront like this, then there will be the propagation v vectors. Or if you got the wavefront as a curve, and we know that basically curve or a circle is basically a combination, a set of all the fragment of little straight line like this, right? So at each point you can always like draw a line that perpendicular to the wavefront at that point. So then that would be the v vector, the propagation of wave, okay? So again, always remember, if you got the wavefront change, then you can see that the wave will travel always perpendicular to that wavefront. So here, when the wave travel to the slit, then based on the Huygens principle, we only have the concept of like secondary source, right? Like basically at first you have an original source of wave, but then after that you can see that wave spread out in space, so that each point here on the wavefront becomes a secondary source, right? Then you can have like thousand, million, infinite point here to be the secondary source. So here, just to simplify, we don't draw everything, but they just show you 1, 2, 3, 4, 5, 6, just 6 of them. But what's the point here? The point is that you can see that from each secondary wave, you can have other mini waves like this, right? It always spread out. But in the end, when you have them superposed, like based on the superposition principle, it basically means like adding up. Like we add up the wave together, then we got this is like the boundary. Okay, this is the final result. This is the wavefront, right? The resultant wavefront. We can see it that way. And from this resultant wavefront, you can see that wave in the end, you see that the wave spreading out, right? Okay. So basically, that's model of the Huygens principle of the wavefront of the secondary source help to explain diffraction. So now we will go into more details why we got this equation in the next video. Okay, see you soon.